So I've been talking to myself for 10 minutes because I've got a realistic 1005 here on the bench, taking the shield plate off to deal with dry joints on the plate, on the non-plated through double-sided printed circuit board. So you've got these rivet points which are just soldered through. And because of unlike metals, you get electrolysis. These are 1987, or this one's 1987. And unfortunately, you've got to take this shield plate off to get to the other side, which is a faff. And this was no receive. And that's what we've done. Just gone through some of these rivet points. And although they look perfectly soldered, there's an example of one looking perfectly soldered. And the soldering iron's not on, so that will be a really good demonstration. I'll do that when I put the shield plate back on. So taking the rod antenna out, taking this sub-display board out, and these also suffer from dry joints, and these are one of those sets that started suffering from dry joints even when they were new, which is a shame because it spoils what are very good radios. Right, has that soldering iron warmed up? Well, that's cut 10 minutes off the video. So I have to take these rod antennas off to get a meaningful set of results, because the rod antenna and its loading code drag on the extension's aerial socket, and you end up with pretty meaningless readings. It's just slightly loose there. It's always well to check these. So we've got two of these for repairing from this customer. And they're both exhibiting similar faults, he says. Now, he did say in his letter, "Hello Richard, please find enclosed two realistic 2005s. Well, I was expecting 2005s, these are 1005s. So I've all got the manual out for the CPT Maxon built 2005, and then we find it's it's this. I don't know. Am I getting this in the right way round? There to there. That's the way. That aligns to there. Good. We'll see whether it still works. It does. Right. I put the display board back. It had some bars out. It probably still does have some bars out. Probably had some bars out when it was new. Well, there you go. So I'll tell you what I think that's going to be. It's not so much dry joints. We'll just go over some of these pins with the fiberglass brush. They're only tin plated pins. Yeah, you see we've got that bar back out. Right, anyway, we'll do the alignment. Need to plug in the extension speaker to our test equipment into the extension speaker socket. This has still got the flaps and they haven't snapped up. They usually go hard and brittle, and they haven't at this stage, he says very carefully. Right, what else? I think we need the service manual every time we get one of these out. Okay, so we've covered this model lots of times before, under 1001. It's the same chassis, just through the LCD display difference. I'm not going to do the VCO alignment because this radio isn't exhibiting those kind of problems. And the snag with that is we have different charging fees for what level of work we do, so I don't want to do unnecessary work, so we're going to skip the phase lock loop section. But you can look in the back catalogue. Test point 3 for 3 volts on L2, and that's receive, and on transmit it's test point 3 and it's TC1 for 3 volts. They have you adjust the frequency at that point. I don't do it at that point. It wants doing into the test set at the end. They're going to have you align the transmitter first. My training is to do the receiver first. No, it's not. It's to do the transmitter first. What am I talking about? They are quite correct to do the transmitter first. Right, so let's have a look at what we can put on the clipboard. So of course I don't charge for dry joints. I don't want to enter into a contract with dry joints. 10 Jan 25 realistic TRC1005 set 1. We'll find a serial number. We will. Four 89382. Dry joints under TX sheild plate. Let's turn the volume down so we don't annoy everybody. Right, transmit. He's actually doing 4.5 watts. I don't want it to do that. It's a 3.5 watt radio. We'll set it for 4. I mean, the current consumption at the moment is 1.1 amps. It says 4 watts on the cover, but it's 3.5 watts. It's 4.5 there, and it's 4.5 there. That's really well balanced. And low power. Is 260 milliwatts. So if you set the power with the antenna connected, we've taken it off, you may end up setting it wrongly like this. Right, 5, 6, 7, 8. Let's find out where we are. Five, 6, 7, 8. And then you've got L8 and L9. L8 and L9. And T8. Five, 6, 7, 8. So we start with T6. Lost my page. T6 is there. There is a sequence to this. T6, T7, T8. L5. Oh, that, no, L5. Yes, not T5 at all. Right, here goes. It was already well balanced, but I need to just make sure it's... Oh yeah, that was spot on. Spot on. Spot on. I think it's the white one for these. It's not the white one. Spot on. So we just need to drop the power preset. And then we've got 4 watts. So it says they want it to be 3.5 watts, and it can be anything between 3 and 4 watts. So we've got it at 4. I've actually got it at like 3.95. And they want it to be drawing no more than 1 amp. So channel 20 is now 4 watts. 4 watts on channel that, and 4 watts on there. They're all 4 watts. Nicely balanced, this one. Go back to channel 20. Let's look at the current consumption. It's now 975 milliamps. So that's now in spec. And what's our low power? Non-adjustable, I'll tell you that. It's 260 milliwatts the same. Back to full power. Let's do the meter check. It's no adjustment on this RF meter. It doesn't have an S meter. It has a battery meter on receive. Meter lamp works. Doesn't have that. Let's look at frequency. The gear's being on long enough now. So we've got 2779104. I will just trim that. Phone's ringing. Right, I'll just get the frequency done. Nice quality trimmers in these. Definitely got something there, haven't we, with that display. We'll do deviation. I'll just see what it is on here for starters. We'll move to the other test set and I'll pop for lunch. Wallow. Wallow. 1.5. This is fun. I've got to kind of talk into it and look over there. Wow, it's 2.4 spot on. Oh, and this set's being well adjusted. My only criticism is it probably wanted doing with the aerial rod antenna disconnecting. But Matt, I mean, these sets are how many years old? I've only started doing that in the last couple of years. Good. Right, I've just got the receive to do. Just to get our initial reading. Okay, let's have a look at the SINAD meter. Oh, I've gone and knocked the frequency, haven't I? Bear in mind, is a factory crystal filtered made by GRE in Japan. So at a time when you weren't getting things with crystal filters, these were. But then they were 119. Sorry, they were 139.99. These. Never as sensitive as you'd hope. it doesn't matter. I tell you what, we'll hold on to the chassis. It's got these range boost side panels, which make you part of the ground plane, so it's only fair. It's just not going to quite do 1 microvolt, is it? See what we can get. So we've got 1.4, no, 1.2 microvolts for 12 dB. Ooh, 0.95 for 10 dB. And then for 20, it's 5.4. Squelch isn't adjustable. Oops, wrong one. Turn it to full. And being a handheld, it's pretty weak. It's 3 microvolts. And the sensitivity of the squelch, wrong one. Always get these wrong, you know. I expect on-off volume and squelch, it's the other way around. Set squelch. It's 1 microvolt. Before we go any further, let's see what the manufacturer says it should do. So the sensitivity for 10 dBs, they want it to be 1 microvolt, and we've got 0.95, so it's already in spec, but we will see if we can improve that. So I'll go and have lunch, then we'll come back to this. Right, let's get this receiver finished off. So 100 microvolts on the signal generator, put the oscilloscope on, we'll set up the detector. As usual, I'll have to remember which one it is. So on the circuit diagram it's T4. Yep, T4. So on the layout, T2. The L12 there is the don't touch done with the spectrum analyzer one for transmit. T1, T2, T3, T4 is the detector. Let's switch to the oscilloscope. Just check that's optimal. Very slightly adjusted. Turn the volume back down to not annoy people. And go through the rest of the tune-up. So it says T4 for best waveform, then T1, 2, 3 and 5. In that order. And 5 being that one. Right, let's go to the SINAD meter. See see whether we can gain anything further. No, I think that was right. No, that's all optimum. Let's get a new reading. It's 1 microvolt for 12 dB. It is 0.9 for 10 dB. And it's 3 for 20 dB. Expect the squelch is the same. Let's just turn that to full. Put the attenuator up on this on the inset. Actually, it's 4.5, which is a little better. And our sensitivity for squelch is 0.3. Good. Switches work, tensiometers work, sockets work, internal mic works. We've just got the speaker to do, so pop that together, put the internal rod antenna back. Right, where were we? Looking for the rod antenna. It's worth more than the radio, isn't it? It's a courtesy. I usually clean the battery contact. I do not test customers' radios on batteries. Bearing in mind we're a trade supplier, I expect people to be able to sort out battery compartments. If people want a retail type of treatment, well, it will be certainly a very, very different tariff. The rod antenna. Come on, Mr. Tango, where's it gone? I've taken the display board out and I found that the resistor net where it's RA2 here, I've unsoldered it and resoldered it, and we've now got a solid bar graph showing. So I'm not charging for that because they're always playing up. There's a shroud goes in there, isn't there? Where's the shroud? It's here. Should have put the shroud in before the screw. Good. tighten these up just snugly at the end now, rather than, it's not good practice to tighten them as you go, or you're going to end up with not everything going back squarely. So there we are. Excellent. I'll just pop it on the aerial. And we'll do an on the air test. One Anna Roger. There we have it, Realistic 1005 late version from 1987. We've got another one to do from this customer. It'll be dry joints, probably somewhere totally different, but it will be dry joints. Very, very good radio. Thanks for watching.